So, welcome to Rajapalayam Rajus College, PG Department of Computer Science, collaboration with IGL Hands-On Private Limited, organizing 5-day International Faculty Development Program on Innovative Strategies in Emerging Technologies. The journey of thousands of miles begins with one step. Yes, you started your one step with our Rajus College. The world is full of diamonds and germs, and we are having some of them here today to build this program. With this note, I would like to give my heartiest welcome to our chief guest, principal, colleague, and participant friends. We need your support to make this event memorable and fantastic. I would like to admit my thoughts. A good event never ends in the world. They take only a fast and keep us awaiting for the next. With the blessings of God, I invite our colleague, Mr. Ganesh Kumar, for delivering welcome address.
Good morning to everyone. I feel great to welcome you all for this 5-day International Faculty Development Program on Innovative Strategies in Emerging Technologies. We have Dr. N. Krishna Kumar, founder, IGL Hands-On Private Limited, USA with us. He is going to knowledge us on mobile edge computing in our first day of this program. I welcome you and extend my thanks to our management, principal, organizing committee, technician, and all the staff members for being a part of this FTP and making it convenient to take place. I welcome and on behalf of one and all present here, let me please extend my heartily welcome you, sir.
Thank you very much, Ganesh.
Next, we are in get together for International Faculty Development Program. I invite to showcase the achievements of our chief guest. I call upon Mrs. Nesrani, Department of Computer Science, to deliver the chief guest introduction.
Thank you, ma'am. Good morning to one and all present here. The fragrance of flower spread only in the direction of wind, but the goodness of a person spreads in all directions. As we have such an inspiring personality, Dr. Krishna Kumar Narayanan, he has a great depth of knowledge in architect systems and software design, advanced technologies to practical solutions, drive innovation in products and write patents. He is a lead to architects and engineers, mentoring students and professionals in technology. He had his bachelor's in applied science from Tyagaraja College of Engineering, Madurai, and completed his master's in electrical and electronics engineering from IIC Bangalore. He received his doctorate from Louisiana State University in the year 1991. He has a wide experience as a senior software engineer in Wipro Technologies, principal engineer in Digital Equipment Corporation USA, and member of technical staff in Silicon Graphics International Corporation, and senior staff engineer in MiraPoint USA, and present he is a vice president engineering in Erico Corporation USA. He accomplished US patents in real-time communication client architecture, system, method, and apparatus for controlling multiple applications and services on a digital electronic device, method, apparatus, and computer-readable medium for multiple messaging session management with a graphical user interface. He published nearly 5 articles in international reputed journals, and also he published a book in an expert system for interpreting mesoscale features in oceanographic satellite image in advanced artificial intelligence application and theory. We are very glad to have you with us in this FDP as a resource person. On behalf of management, I once again welcome you, sir. Welcome you.
Thank you, madam.
And thank you, sir.
Thank you, Nezrani ma'am. Education is the passport to the future. For tomorrow belongs to those who prepare for it today. Education is the most powerful weapon we can use to change the world. Now, the person who has consumed himself to change the society of light, the darkness in the life of our child. The chief guest, Dr. N. Krishnakumar, is requested to address the audience.
Thank you very much, madam. First of all, I'd like to thank entire RRC college management, Deepa madam, Ganesh sir, Nasrani madam, and the entire management staff for giving us an opportunity on behalf of IGL Hands-On. I'd like to thank all of you for inviting us for this wonderful week-long faculty development program. I know RRC and IGL Hands-On, we are not new, so this is yet another chapter in our partnership. So first of all, like I said, thank you for this opportunity. And I also would like to thank all the IGL hands-on members, Rajesh Kumar sir and Ragbati sir, who had tirelessly worked behind the scene to prepare for this seminar. And glad everything is working out good. So with that, I will start sharing my presentation, and then we'll walk you through some of the material that we have prepared today. Okay. Just a
Sir,
moment.
you go ahead. You go ahead, sir.
Thank you.
Sir,
Can you,
start your share your screen, sir.
can you see my presentation, madam?
Yes, sir. Yes, sir.
Oh,
Yes, sir.
very good. Again, so this is the not the first seminar with RRC. I remember we had two in-person seminars in RRC. We had one done on 5G networks, as well as on how to prepare the students for the next generation technology. This is what IGL Hands-On is all about. We are striving to make sure that we can help the current college students and the faculty to make sure that we are aligned on the technology from the industry point of view. While most of the college professors and teachers, they focus on the curriculum, we come in from the industry background. We want to complement our industrial experience in the form of hands-on projects. And this is what we have been doing it for the last 3-4 years. So I'm very glad to be part of our fourth webinar. This is called Mobile Edge Computing, another fantastic topic, very hot in the field these days. So what we will do is we'll go through the presentation, and of course, many of you would have heard about edge computing, but we'll touch upon some of that aspect as well. So without further ado, let me go to the next slide. Okay, our outline for the presentation will go something like this. We'll first talk about the definition of mobile edge computing. Before we do that, we'll understand what is edge computing. What is it needed for? Why are they needing it? What are the typical use cases people do? And then specifically focus on the mobile industry, because these days, whether people have laptops or PCs or not, people have mobile phones. So the world has gone mobile. So mobile is part of our life. And so it is very important to address a very important technology such as edge computing. How is it applicable for mobile networks? So that's the topic for today's webinar. And it's also short form for MEC. And so after the definition, we'll also talk about what are the benefits, why do we need this? What are the technical advantages and the business or the commercial advantages of mobile edge computing? Because if we don't know why we're doing it, there is no point in doing anything. So the important question in any technology or area of expertise or research is to ask the question why. So that's what we will try to answer in the benefits. And then I threw in a bunch of use cases. Anytime you hear about edge, some of you would have related this to IoT, Internet of Things, which is very common because edge computing was actually started with IoT as the market segment to begin with. But over the period, it has widened its wings and gone beyond IoT. It has gotten into automotive industry, telecom industry. So these are the three areas that we will cover as part of the use cases. We'll definitely talk about one of the IoT use cases, what is happening in a manufacturing plant, how is edge computing is helping them to solve their manufacturing processes and efficiency and speed and so on. Likewise, we'll touch upon automotive, especially on self-driving cars, vehicle-to-vehicle communication. There is a brand new area that is opening up for that type of a field, and we'll see how edge computing is playing a major role in there. And last but not least, we'll talk about telecom. Telecom is all about mobile network operators, whether it is Reliance, Jio, Airtel in India or in other countries like US, Japan, and India, Korea. People are beginning to talk about bringing in edge computing as part of their mobile networks. I mean, these days, as you can very well see, mobile network operators, they not only provide voice services, they provide data services. I mean, these days, if you go buy a smartphone, many of us are asking, what is the data plan looking like, right? The voice call is becoming more and more secondary because more and more consumers are using app-based usage rather than calling, and of course, messaging is also becoming very popular. So we'll take a look at some of those use cases and see how mobile operators are cashing in on this technology. And also, there is a new trend in the so-called video conferencing, like the one that we are going through because of this COVID situation. Just about everybody is having webinars and web-based conferences, whether it is Zoom or Google Meet, you name it. So telecoms are also getting into that space because they see that more and more of their subscribers are coming in or logging in from their mobile phones. So they want to be part of that experience for a video conferencing. So those are some of the 3 use cases that we will take a look. And MEC is also these days bundled in as part of a 5G service. Some of you would have heard about the 5G networks. Of course, many countries are either already deployed 5G or they are in the process of deploying, active trials going on. So this is the next generation to 4G networks. So as we all know, many of the telecom operators offer 4G LTE. Now they are migrating to 5G. So what is an advantage of a 5G? In addition to the typical advantage of having a faster network, people are also considering how to bundle multiple services that you can be active at the same time. So can I have a seamless service continuity? Can I start a call with a mobile phone and pick it up on my tablet? Likewise, can I pick up a message that originated from my phone? Can I pick it up on my laptop? So these are the kind of service continuity technology that 5G is offering, and mobile edge computing is going to play a major role in the 5G services. And then, of course, we'll talk about some of the key players because I'll talk about the edge computing definition in a minute. Some of the cloud players like Amazon, Microsoft, and Google, they're also beginning to play in the edge computing space. So we'll take a look at some of their offering, and some of them are ready. Some of them are ready with solutions that telecom operators can use. So we'll take a look at some of those examples as well, and then we will conclude with any Q&A from the audience. So just a quick walkthrough. We'll take a look at the definition, why is it needed, some important use cases, and then some key players, and then open it up for questions. Okay, so that's what we are planned for today's webinar. Okay, so this slide that talks about edge computing. This is a very simplistic view of what an edge computing architecture would look like. As you can see in the top, there is a cloud layer. All of you must be very familiar by now with cloud computing. In fact, whether you're in an university, college, or company, or even home, we're all used to using cloud technology. Google Drive, OneDrive, those are all very household names that people are using it these days. It is so popular, whether we keep our photographs, pictures, documents on the cloud. But in addition to storage, the cloud services also provide computing. You can have virtual machines instead of having your software running on your PC. You can run them on their virtual machines. They also provide storage and networking. You can connect to various other third-party services, network elements. So the cloud providers are very well established in the last 5-10 years or so. And if you take a look at the bottom layer, this is where we as consumers are, right? We are the consumers who carry the cell phone or laptop or PC. We consume data. Traditionally, many of the applications, even the one that we're doing right now, we consume that information through cloud, right? So that is what is happening, which is typically okay. In fact, 99.99% of the applications that we run today on the cloud, they run just fine. There is nothing wrong with that. But then there is a set of applications and services where the distance between the devices that we are consuming the data and the cloud itself could be a problem. So I'll give you some examples of that. Peer-to-peer gaming, augmented reality, virtual reality, some of the automotive use cases, vehicle-to-vehicle communication, where the latency, that is the round trip time from the time your device makes a request to the cloud and the time it gets the data back, they're all in hundreds of milliseconds of time, which is okay for if you're browsing, if you're downloading some videos, those are fine. Even taking classes are fine. But if you're in a very mission critical application like vehicle to vehicle communication, where the decision has to be made within single digit milliseconds, then the cloud distance is going to be a problem. So this is why in the last 4 or 5 years, the industry has come up with a technology called edge computing. So what they did is they introduced a layer between the subscribers and the cloud layer. It's called the edge layer. Then there are so-called edge nodes and edge computers, edge devices. So they're all part of this layer. So the idea behind this edge layer is to keep the computation and the storage close to where it is needed. So basically, if two users are in a conference call, or two vehicles are communicating, you want to keep the data as close to them as possible. So you would see in some of the examples that I will show later on, you bring the application servers that are providing you all that functionality, not keep it in the cloud, but keep it closer to the devices. So that is the primary definition of edge, that is bringing the computation and the storage close to where the users are, as opposed to doing it in the cloud. But keep in mind, edge computing is not going to replace cloud computing. That is not the intent. That is not the objective at all. But the idea is to enable certain applications and services to run better, to run faster, to run more efficient, to have better security, better privacy. So there are many, many characteristics of certain applications that require these characteristics. You want to keep them in the edge layer, not on the cloud layer. So the edge devices typically they serve the consumers with that service, but they also communicate with the cloud if they want to store some data for logging purposes, or any other reasons why they want to store data on the cloud. So that has not, this link has not gone away. So this is a very simplistic definition, but of course, edge computing being very new in the industry, you will find many different definitions of edge computing. So don't be alarmed if you see different definitions of it. But I just want to make sure that the takeaway is that it is a layer that is between the devices and the cloud that enables better services, which I will cover in a minute. Okay. So we looked at what is edge computing. At least we have an idea of what edge computing is. Now, what are the benefits? Why do we need edge computing? I think there are several characteristics in this slide. I summarized some of them. So for example, the very first one is the speed, which is to say that we need to reduce the latency compared to what typically happens in a cloud access for data. So this is very, very important. I think the use case that I mentioned about vehicle-to-vehicle communication is a classic example. Mission critical applications, healthcare, right? For example, senior care. There are a lot of products out there in this COVID situation where senior care centers, people cannot go in. They need to be monitored, right? They need to be monitored whether they're doing fine or not. There are many, many devices that they carry that needs very near real-time responses. You don't want that to be held like any other call. So speed is very, very essential. Efficiency. So in the case of IoT, I mean, one classic example that I would give for efficiency is one of the use cases of edge computing is IoT. And then you would have probably heard about smart cities, right? Where the city government, they plant so many of these street lights, smart street lights. They not only give you signals, but they also have monitor the traffic conditions, whether they may have a camera in front of them or they may have some sensors. So they would all talk to a centralized edge node. And rather than each one of those, if you take a typical city, you could have thousands of hundreds and thousands of these little devices. You don't want all of them to be talking to the cloud, and that introduces a lot of inefficiency. And most of the time, the data that they send to the cloud is, I'm doing fine. I don't need any maintenance. So a lot of the time, the data is unnecessary data. It is necessary only when something goes wrong. So it is very important that we don't send all of the data from these millions of devices to the cloud. So that's not efficient. So one of the ways that people have solved that problem is in the smart cities IoT example. They would go install edge gateways. Let's say in every street or every other street, they would have edge gateways that talk to the local signal sensors, and then they analyze and say whether if the data is good, then they don't bother sending that information to the cloud, or they collect a whole bunch of information and send it to the cloud at once, maybe at the end of every day or the end of every week. So this is the way they are addressing the efficiency issue. So definitely edge computing brings in efficiency in the system. Privacy and security. Another example is manufacturing plant. Let's say if you're in a manufacturing plant situation where your data, what you're manufacturing, how you're manufacturing, your process quality, your yield number, everything is going to be so confidential. You don't want that information to be out in the public in the cloud. So there are some use cases where the company wants to keep all of the data locally in the manufacturing plant itself, so that way they can maintain the privacy and the security. So this is the one use case where in the manufacturing floor, I have a use case that talks about it, where you keep all the data in the manufacturing building, where all of them talk to a node edge gateway in the plant itself, and then only when needed, the data goes to the cloud. The next point is scalability and reliability. I think in the smart cities case, I talked about multiple sensors talking to an edge gateway. You can easily scale, right? For example, if you want to add more street light sensors, you don't have to go change anything in the cloud virtual instance. You can just go modify your edge gateway in the street, so it becomes very easy to maintain. So it scales much better. Reliability. If some of them goes down, you don't have to worry about the entire system going down. So inherently, the distributed computing nature of edge gateways and computing brings in the reliability and the scalability aspect of it. Versatility. This is a great advantage of edge computing, because these days many vendors like HP, Dell, Intel, IBM, there are many vendors who provide edge gateways, edge routers, edge computers. So you're not tied down to only one vendor. So that gives you the versatility. So you can buy from a different vendor, so that keeps the cost down as far as deploying your edge network in your environment. And last but not least, reduced cloud costs, right? I think all of these things, what it culminates in is you are keeping the cost down for a public cloud. I think one of the things that it's very public knowledge, large companies are beginning to question, why am I paying millions and billions of dollars to Amazon and Microsoft for cloud storage and cloud computing? What does it take to bring it into my enterprise? So definitely, people are looking at edge computing as a way to optimize their cloud costs. Of course, they cannot get rid of the cloud, but they can minimize the amount of data that is going to the cloud from their environment, and try to do most of the activities within the edge network itself. So these are some of the benefits of edge computing. So let's go to the next one. As I said, let's take a look at some of the use cases. So the very first use case is an IoT. So here is an example of a manufacturing plant in Japan, Daihan factory specifically. What happens here is a manufacturing line where there are parts that are moving in the conveyor belt, and then there are RFID readers that read information from the parts, and then they need to in real time determine whether the part is defective or it can continue on the conveyor belt. Should I put it in the defective bin, or should I continue for the next process in the assembly? So this is a typical system that happens, and what they've done is they've created an edge system called the foghorn. So the edge node here, it will talk to all the RFID readers, collect all the data, and analyze them, do the analytics locally in the plant itself. And in the process, what they do is they have this edge intelligence. So they create this edge intelligence within the manufacturing plant itself. So it analyzes the sensory data. It analyzes faster because it's at the edge. and only when it is ready to be shared with the cloud, then it sends it out through the internet, through the to the cloud services that they have. So the way the operational engineer would be looking at the output from the edge node rather than from the cloud. So all of these operations are local. So all the benefits that I described before are applicable in this use case. So they have published a lot of materials on the internet. So yeah, please go ahead and take a look at this use case that is called Daikin Factory in Japan, where they have extensively talked about how they have implemented an edge-based system for their manufacturing plant. So this is a classic example of how edge computing helps IoT. This is the second example. It's automotive example. Like I mentioned, right? If you go buy a car these days, there's a lot of electronics, like a lot of sensors. Unlike the olden days where you have a lot of mechanical parts, but these days vehicles and cars come with the computers, onboard computers, sensors, and then now they're getting equipped with many more IoT devices where they can communicate. Of course, car antennas for calling and messaging have been around for a while, but the industry is now moving to a new initiative called V2X. V2X stands for vehicle to X stands for anything. X for anything. That means vehicle to vehicle, vehicle to operator, vehicle to traffic light, vehicle to a user. So all these communication examples are classified under this V2X umbrella. It's a very big initiative in the industry, and many hundreds of companies are involved. All the automobile manufacturers, mobile operators, technology companies, the IoT manufacturers, they're all involved in making sure that the V2X technology is rock solid. The way it works is, for example, vehicle to vehicle communication. So they can talk to each other and make sure that there is a safe distance maintained. This is huge, right? If you think about the amount of accidents that they can prevent, and the impact on the insurance industry, it's very big. Likewise, the vehicle can be talking to a traffic light. So these are typical example, like people go on beating red signals. Those things can be minimized or even completely avoided if the vehicle can communicate with the traffic light and start applying brakes right away. So you're not waiting on the driver to make those decisions. The vehicle will make those decisions for you, and hopefully they'll be a lot more reliable over time. But this is a very active area of research and implementation. So this is one example. Likewise, vehicle to vehicle, and then most of them they talk to a edge cloud. They call it edge cloud in this example. But basically, idea is all these devices or the vehicles, or the devices within the vehicle, they'll be talking to an edge gateway, where the edge gateway does all the analytics, intelligence, and then make sure that the responses go out right away. Another example is autonomous driving, right? The driverless or self-driving cars. Clearly, it needs to have responses very quickly. So all the responses will come from the edge cloud rather than from the actual cloud. So for all of these reasons, this is an example where automotive industry is benefiting from edge computing, and it improves the speed, security, reliability. Those are all very important for this industry. So this is a second use case where one could think of how edge computing is playing a role. So we looked at IoT, we looked at automotive. Now we are coming to the crux of our presentation. So we looked at what is edge computing, what are the benefits. We looked at IoT use case, manufacturing plants, and we also looked at the automotive use case. Now, let us take a look at the telecom use case, which is a very interesting one. And hence our topic is called mobile edge computing. It is also called as multi-access edge computing. It is a very big industry effort that is going on in the standards industry. Standards are being developed by European Telecommunication Standards Initiative. So what they do is, before I get into the actual mechanics of it, if you think about mobile operators, whether Reliance or Airtel or Verizon here, take any one of these operators. They used to be the old Graham Bell based telecom companies, right? They used to make phone calls. So they started out as providing voice services using an 100-year-old circuit switch based technology. But now, with the 3G and 4G LTE, just about every voice call that happens on the mobile network is an IP-based call. That means they're no longer based on the circuit switch network. They're based on the IP-based network. So they're all becoming IP-based service providers. So they are beginning to play a role in more and more in IP-based services, whether it is voice calling, messaging, video calling, broadcasting, anything that they do today to consumers, mobile consumers, it's all based on IP, the Internet Protocol, which is the backbone for all of the traffic that goes on the internet. So there is the line between a mobile operator and other service providers or solution providers like Facebook and Apple and Microsoft. The lines are blurring. So more and more collaborations and even sometimes competition is also happening between the mobile operators and the internet players. So what mobile operators are trying to do, they're trying to move their services, especially voice messaging and video, including broadcasting, closer to where the consumers are. So this is where I believe mobile operators are going to tremendously benefit from edge computing because they own the subscribers. Like for example, when you and I go buy mobile phones, we always associate with an operator, and so any services that they offer, if they do any improvement in their service quality, that is going to look a lot better. So that is the power of mobile edge computing. Here is a simple diagram where I thrown in the key players. At the top, you have all the cloud providers like Amazon, Azure, Google, IBM, and so on. These are the public cloud providers. And in the middle is operators, Reliance, Jio, and Airtel, Verizon, AT&T, you name it, right? All the tier one operators, they own the mobile core network through which all the services are offered. And here is where you and I, the mobile subscribers, this is where we are. And typically, when today without edge, when we avail a service in the cloud from the mobile subscribers, it goes to their core network, the request, and then goes to the cloud and then come back. So the traffic is between the device to the core network to the cloud and come back. So what mobile operators are trying to do, they're trying to install these what are known as MEC, mobile edge computing servers in their network, sometimes even in their base stations. So that way, the traffic is limited between the device and the MEC, and it does not go to the cloud at all. So this is an example of an edge computing paradigm where the mobile operators are trying to improve the efficiency, the speed, and provide a better quality of service for their mobile subscribers for providing these application servers called MEC application servers. So I'll give you some examples of this a little bit later. But this is the crux of mobile edge computing. And we believe mobile operators are well positioned, and some of them are already moving in this direction with a lot of edge computing initiatives. And so they're trying to bring in applications and services from the cloud into MEC. So as a consumer, let's say if you are a mobile game player, right? If two mobile game players are playing the game, the traffic will be primarily limited to within one server. So that's one use case. The other use case is, let's say you are in a cricket stadium, you're watching, hopefully after the COVID-19 is behind us, we'll all get back to watching sport events, cricket, football, and other events. So what happens is the operators are deploying these edge routers and edge gateways inside those stadiums. So anytime if you want to do a replay of something that you just missed, let's say you missed a foul play, you want to immediately take a look at the replay, you can do that with using the services that the mobile operators will provide, and all of them are going to be enabled because of the edge computing, because the traffic doesn't go beyond the stadium. So they kind of keep it within the stadium itself to provide you that better experience for subscribers. So this is a very important slide. Like I said, in one webinar, it is difficult to explain everything that is related to mobile edge computing. But if this is one diagram, I would like you to take away with this is the diagram. So cloud, edge, and the subscribers. Okay. Let me see. I think I'll hold off for any questions at the end. So let me just complete the presentation first. Okay. So like I mentioned, 5G is important for the mobile operators, and many operators are beginning to offer mobile edge computing as part of their 5G offering. And this is a very clever marketing game, and that is because they are promoting collaborative gaming, real-time communications, video caching, mobile games that I talked about. So here is an example, right? So if two mobile game players are involved in an internet-based mobile game, then all of them are going to be handled by the mobile edge clouds within the operator network. So the traffic never leaves the mobile network. So the cloud is very far away. Enterprise cloud is very far away. So whether you're in video conferencing, whether you're in a telemedicine video conferencing, like with all this lockdown we are in, the healthcare providers are now trying to talk to the patients using video conferencing. So it is becoming very important for that type of a care to have very good quality. You don't want to have a lot of dropped calls and the blurry video and things like that. So in order to do all of that stuff, mobile operators are bringing in those services from the public cloud into their edge clouds. And so that way the experience for the consumers is a lot better. And so they end up paying more for those services. So that's how the mobile operators make their money. But the bottom line is they are targeting 5G as a vehicle, right? I mean, these days what happens is when the mobile operators, the marketing goes something like this: we have been offering you 4G services. We'll give you a 5G subscription upgrade. By the way, we have added a few more applications and services that would work better on 5G, but they would not tell you anything about the edge computing. But edge computing is the backbone for a lot of those activities. So the same thing with AR, VR, and real-time video conferencing, including the mobile video conferencing that happens today. In fact, I forgot to tell you one thing. If you think about in the mobile operator space, we all know, right? These days, because of the situation we are in, a lot of video conferencing and messaging rooms are happening, and Zoom is becoming a household name, right? Just like Google, people are saying, let's say Google it, let's Zoom it, right? So Zoom is becoming very popular. Because of that, many other services like the one we are using now, they are getting popular as well. Because of this growth in this messaging rooms or video-based conference services, mobile operators are beginning to look at that as a very lucrative area. So case in point, there was a company called Blue Jeans. I don't know if you've heard of them. It's a US-based company, and they were serving mainly enterprise customers. They were competing with Zoom, and they had a pretty decent subscriber base. And Verizon is a mobile operator in US. They recently bought them for a good chunk of money. So clearly, operators like Verizon, they want to offer very high quality Zoom-like video conferencing services to their subscribers. And guess what they're going to be doing? They're not going to keep the Blue Jeans servers in the cloud. They're going to keep it within their mobile network. So I think there is also Geo has a Zoom-like app, right? So these are all examples of how mobile operators are beginning to use the edge computing to offer differentiated services because they take advantage of the situation, and the demand, right, is very high. I mean, these days, another example I can think of is today, a lot of the people get their internet connection through the mobile operator, right? You not only get a smartphone, they also give you a DSL connection, or they give you a wireless internet connection. Or they give you a little device like the Geo dongle device that people buy. And at least in US, what we have heard is the demand for those internet devices have gone through the roof, mainly because in a household of four, mom, dad, and two children, it is very difficult to have the same internet connection shared, especially when during a work day, parents are working over video conferencing, and the children are taking classes, or they're doing any gaming activity, whatever they do, the internet usage has gone through the roof. So because of that, the operators are beginning to deploy a lot of these internet devices, and a lot of them, they want to keep it very close to the edge, so they can offer better quality of service. So some more examples of how mobile operators, especially tier one large operators, are coming in and offering those services and taking advantage of the edge computing. So that's what I was going to say here. So the marketing game is 5G, but other than that, the technology behind it is all mobile edge computing. Okay, a little bit more on mobile edge computing. I think I already talked about this a little bit. It's a distributed computing environment. So what they do is they take all the application hosting services that are typically running on the cloud right now, bring them to closer to their network, in this case, mobile network. And the mobile application, the MEC application server, the little boxes that you saw here in this diagram, these little servers here, they are called the MEC application servers. So that's those application servers, they provide the exact same functionality that your Amazon Web Services provide: computing resources, storage, and network connectivity to the radio access network. So those application servers are also going to be important. We already talked about standards. Hundreds of technology companies are involved in building the standard, because this is going to be the future. So edge computing is going to be the future for mobile operators, that's for sure. Clearly, enterprises and other manufacturing companies, they're also adopting the technology, but more than anybody else, mobile operators are clearly involved. So if you go to internet and search for ETSI, you'll see a slew of companies. All the name brand telecom companies are involved, including Huawei and Telecom Ericsson. You name it. If you are in the telecom industry, that company is involved in contributing to the standards, and so that is an important thing to watch out for. Okay, so now we have learned about operators, mobile operators. They are bringing in the services into the edge. How are they doing it, right? Are they doing it all by themselves? Are they getting any help from anybody? It's a mixed bag. So some operators who have deep pockets, who have large engineering departments, they go build the edge network by themselves. But many other operators, they rely on the cloud players. Because if we go back to the very first diagram that I shown here, let me go back to that real quick. So in this diagram, as more and more enterprises and the consumers demand edge layer, the cloud players are beginning to see the threat, right? So Amazon and Microsoft and Google, the large public cloud players, they see the edge computing being a threat for them, because more and more traffic is not going to reach their cloud anymore. It is going to be terminated at the edge layer, and so their cloud revenue is going to be going down. So they saw the threat a few years ago, and so instead of they cannot resist that, because this is something that is going to happen anyway. And so what they did is they started offering edge services by themselves. So all three of them, Amazon, Google, and Microsoft, the cloud providers, they offer edge services. So this is what I was going to cover in this slide, where there are two popular edge services that I kept on the slide. Amazon Web Services called Wavelength. So please, if you are an Amazon Web Services subscriber, you can go to the management console and look for Wavelength. Wavelength is a service that is intended for edge computing, and it offers single-digit millisecond latency, which is fantastic, right? I mean, just order of magnitude faster than a typical cloud service would give you as far as latency is concerned. So this is very, very important for mobile gaming, vehicle-to-vehicle communication, all the mission-critical applications and services that we just talked about. So Wavelength offers that. And what they've done is they've taken all the popular services. I mean, if you're a Amazon Web Services subscriber, you would be familiar with some of these terms like the EC2 instance, VPC, databases, and cloud formation, and several services that they offer as part of AWS. They are now porting. Some of them are already ported. They are available in Wavelength. So what that means is, if you've written a program, if you've written your application for AWS using any one of these popular tools, they're readily available in Wavelength. So which is great news, right? So this is what, as developers, people want to see, that they don't want to write, because the typical question that I get is, I'm a cloud developer. Now there is an edge computing coming up. Should I become an edge developer, right? So that's a very logical question. So Amazon and Microsoft has addressed that question. So what they're telling them is, I'll also show you in a minute. We can go to the website and take a look at that. So any application that you've built on those can be easily migrated to Wavelength, and so that makes it very easy. If you are a cloud solution provider or cloud developer, you can start migrating to Edge fairly quickly. And all these the Wavelength services from Amazon is adopted by Verizon, Vodafone, KDDI, and SK Telecom. So as you can see, Verizon is number one in US, Vodafone is number one in Europe, KDDI is close to number one in Japan, and SK Telecom in Korea. So large mobile operators, they have adopted a Wavelength. So that clearly shows that this is going to become a very popular edge computing platform. So in your college, I mean, I used to have a slide in terms of how to build an edge computing lab in your college. If you're thinking about doing some projects around edge computing, yeah, please take a closer look at AWS. You can create some emulation, simulation environments in your college where some of the applications and services that you developed using AWS, you can do them using Wavelength and show it to industries, and even work with some of the telecom operators in your country. And some of them could be benefiting from such a research lab in colleges where faculty as well as students, whether it is undergrad students, postgraduate, graduate students, PhD students, they can all work together and create an edge computing lab. And right now, the software tools are available. So that's a good news as far as starting something in the colleges. You don't have to wait for anymore. This is readily available, and some of the operators are already beginning to deploy them. So one use case I can think of, like I said, right? Let's say Verizon, once the Wavelength porting is complete, they would announce and say, hey, if you are a mobile game provider or a supplier, maybe mobile game player, suddenly your games will be order of magnitude faster. And so that is how they would market, and then they would get additional charges for that because they need to compensate for the additional hardware that they are putting in their edge computing. So that's an example of what Amazon is doing. Microsoft Azure has an edge component. It is again for ultra low latency for applications. One of the interesting things that Microsoft is doing is, I don't know whether you have been following, they've been buying telecom companies. So recently they bought two telecom companies, mainly because Microsoft sees that the needs of the mobile operator are all IP based, internet protocol based, and it's all software. It's no longer about creating a circuit switch call, making phone calls. Everything is IP based. Everything is software based. So they're trying to provide what are known as virtualized network functions. The official term is called VNF. So all the telecom services like billing and charging and all these services can be virtualized in the cloud. So the operators don't have to keep paying lots of money for their data centers. So Microsoft is helping them run some of the services in Azure, and they're extending that out to have edge computing as well. So for any mission critical applications, folks can use their Azure Edge cloud platform and start bringing those services from the cloud to edge. So those are two examples. I'm sure if you look on the internet, there are many more examples, but these are the two popular edge platforms, software platform that are available today. If you want to build a edge computing lab, or you want to do a project in edge computing, these are the tools that I would recommend that you can start taking a look at. So I'll go through this reference quickly, and then I'll walk you through the AWS wavelength itself. So here I just threw in a bunch of references that we have used in the presentation. If you rewind a little bit, we talked about edge computing and some of the important vendors who are in the edge computing, and some connected car examples that we talked about are kept here. And then specifically about wavelength, Azure Edge, and the mobile edge computing. So I'll share this presentation offline with RRC, so you can go and take a look at some of these references for further reading. But like I said, it's a very fascinating field. It's a fast-moving field, so there's a lot to catch up when you want to get in. But the good news is the momentum is building now. Somebody said 2020 is the year for mobile edge computing, and I'm already seeing the signs of it. The fact that Verizon is buying Blue Jeans, Microsoft is buying 2 telecom companies, and the wavelength is being adopted by major operators. Those are all indications that the mobile services that we know today are going to be a lot better, and they will all start using the mobile edge computing. Okay, any questions before I show the actual website where AWS wavelength is? Let me pause here, see if anybody has any questions. Okay, let me present the wavelength, just a minute. I'm going to share my browser, just give you live some walkthrough of AWS wavelength. Just a moment.
Sir, queries will be displayed on your screen, sir.
Okay, sounds good. So let me just show this real quick, and then I'll come back to that, madam. Give me a second. Okay. Yeah, I got it. Okay, are you able to see my Google Chrome screen?
Yes, sir.
Okay, so you can just Google AWS wavelength. It'll take you to the wavelength services. So you can see here, it is part of AWS. It builds application. There is a single-digit millisecond. This is what I talked about, and it brings AWS. Amazon is also now tying wavelength to the 5G network. So they are playing the marketing game. So everybody is rallying behind the 5G networks because that is how they're going to be making money, the mobile operators. And so this is what I said, right? Typically, the latencies are more than 100 milliseconds if you go to the cloud, whereas if you go to something like an AWS wavelength, it will be in the single digit. And all the services that I talked about, the VPC and EC2, they're all available in wavelength. They call wavelength zones. So if you go to your console, you'll be able to see them as well. Like I showed you, these are the partners. So all the mobile operators in the world, they're adopting AWS wavelength as we speak. And some of the benefits, we talked about ultra low latency, consistent AWS, because if you're used to AWS experience, then you will have the same experience when you go to the wavelength as well. And the global 5G network, flexible, so all those benefits. And then here is a small diagram that show how it works. So if you, let's say if you are a cloud developer, you have EC2 or VPC, then you extend the console to create a wavelength zone. So you can take some of those programs and move them from your AWS instance to wavelength zone. And once that is available, then it is a lot more closer to your application is. So the application traffic goes to the application servers, and then they stay back within the wavelength zone itself. So very cleverly done. And we talked about some of the use cases. Let's say I think they've given application use cases. Game live video streaming is a classic use case. Because of the situation we are in, the live video streaming is in great demand. So this is the reason why, in fact, I was reading an article today that COVID-19 has accelerated the mobile edge computing need. So more and more telecom operators are blaming it on COVID-19 and say, yeah, because of COVID-19, we need to accelerate our edge computing programs, and that is going to be a big boost. So if faculty or student or anybody who's interested in the research and development, you cannot go wrong if you select the mobile edge computing as a field. Machine learning is another example. AR, VR, another classic example of how they think that AWS wavelength will help them. Okay, so I think that is.
So questions displayed. Questions are displaying in your screen. Sir.
Yeah, let me see. So I go to the live comments, right?
What are the protocols used?
Okay, what are the protocols? The protocols used are very similar to our web protocol: HTTP, HTTPS, all the usual web protocols. There is no special protocols for edge computing because we are moving those services from the cloud to the edge. So those applications will do exactly the same. So all of your encryption algorithms and protocol that you've used, SSL, TLS, you name it, all the web protocols are applicable for edge computing as well. So there's nothing special for edge. Good question. Yes. What is the second one? 5G.
5G.
Yeah. So definitely, as I mentioned, 5G is definitely all the operators are moving towards that. Whether we like it or not, 5G is going to become reality. It has already happened reality in some of the countries, and mainly not because of the speed itself. There is a phenomenon called fixed wireless convergence. So they want to have all the networks like we have today, all the wireless networks today. If you take a look at, we have cellular wireless networks, Wi-Fi, Bluetooth, near field communication. So there are so many of these wireless networks, but applications are they need to be homogeneous. So this is what I said. Yeah, I can start my messaging or a call on Wi-Fi. I should be able to continue on Bluetooth. I should be able to continue on my cellular network. So 5G is going to allow me to do that service continuity among networks. And yeah, it is going to be very useful. Mobile edge computing is going to play a major role in the success of 5G. Because what happens is when consumers, when they look at going from 4G to 5G, the expectation is that they want faster, better quality, high definition video, and no call dropouts, and faster gaming. So they will require, the demand from the consumers is going to be so large. Mobile edge computing is a must-have for these services to work flawlessly. So this is the reason why telecom operators like Reliance, Jio, Airtel, and all the tier one operators in the world, they're investing heavily in 5G and especially in mobile edge computing. Any other questions?
Sir, our principal is waiting for giving special address, sir. Sir, after that session, we can continue our question session, sir.
Sounds good, madam.
Sir, I invite our principal, Dr. Jagannath, to address the gathering.
Sir, good morning, sir.
Good morning, sir.
On behalf of Rajapalayam Rajus College, really we are so happy that we would like to congratulate our IGL hands-on team, Dr. N. Krishnakumar sir, founder of this IGL hands-on team. Really, you are doing commendable job, sir. Commendable work for our students by providing various projects in emerging technologies. Really, we are wholeheartedly we are thankful to you, sir. And Mr. Rajus also member of this IGL hands-on team. he is giving more support to us in all the way. And also Mr. Raghupathi Raja sir, member of IGL hands-on team, who is functioning as the bridge between our Rajapalayam Rajus College and IGL hands-on team. And moreover, our chief guests from IGL hands-on team, I would like to congratulate and appreciate all of you for your effort to make this program in the successful way. Moreover, our Deepa madam, our computer science department HOD, and the department staffs and everybody, really they are doing commendable job. Really, I'm very fortunate and proud that we have a very good team. Moreover, I would like to congratulate the participants also, because this is the golden opportunity, and all the information are very vital one, and it giving motivation for all the participants also. So really, I'm so happy that for this wonderful event. Once again, I thank Dr. N. Krishnakumar sir for this making this event a wonderful way. Thank you very much, sir.
Thank you, Dr. Governor sir, Principal sir.
Yes,
I
sir.
think it means a lot for us. Like I said, it's our pleasure to serve
Yes.
partner colleges like, and certainly mentioned all RT members, IGL team members, they are working together, and hopefully we'll do a lot more. I think we're just starting the journey, and hopefully we'll do a lot more to help the students. That is our
Okay.
basic premises. Thank you very much, sir.
Thank you, sir. Thank you very much, sir.
Sir, thank you for your special address, sir. Sir, let us continue our question session, sir.
Sure, madam. Yeah, the near field communication is something that that is becoming very important in e-commerce. Like for example, today you can have wallets, e-wallets, and many services that are using near field communication. So it is sort of a communication that is it is not going to be alone helping 5G, but it is going to be part of the 5G ecosystem. So that's the way I would view it. So people are leveraging the NFC for its the privacy and the security, right? Most of the other wireless communication, whether you take Bluetooth or Wi-Fi, they're long range. When I say long range, definitely compared to NFC, it is definitely long range. So there are always concerns of somebody spoofing in into collecting your data from Wi-Fi or Bluetooth, whereas with the NFC, that chances is really zero. So as more and more NFC based services are developed, they don't want to leave behind for the 5G. So anytime when you want to do, let's say if you're in a financial situation, you started a transaction with one and then go into the next one, you want to continue the same NFC approach rather than doing it something entirely different. So that is the approach that industry is taking. But it is also going to be very interesting to see how 5G is going to adopt NFC and what additional services that it will bring along. It is still too early to tell as far as the interaction between NFC and 5G is concerned. So I would say stay tuned, and we'll learn more. Next question, please. In today's technology, NFC, at what extent will it be possible? So I don't understand the question. So maybe you can rephrase it in a different way. Any other questions, madam? Yeah, I think I would like to avoid those political topics, whether 5G will destroy all livings. This is a technical seminar. So I think we are here to talk about the technical aspects of 5G and its benefits. It's a very different topic, whether how it is destroying environment, how it is politically changing. That is different webinars. So I would stay away from those type of topics today. Thanks for the question, though. Same response. I think 5G affects humans. I would stay away from the topic for today's webinar. It is not in the scope of what we wanted to cover. Today, we wanted to cover mobile edge computing, and 5G affecting humans is not part of the subject. So I would avoid answering those questions. Thank you.
Thank you so much, sir. That was indeed motivating and extremely informative. We are so honored and privileged to have you among us as a RFC family member, whom we would like to appreciate now. With this, we are in the end of the day one International FDP. I call upon Ms. Saranya to propose the vote of thanks.
A warm and grateful morning to our most valued Honorable Chief Guest, Management Committee, worthy faculty members, my dear friends, and everyone gathered here. It's my privilege to purpose a vote of thanks speech and acknowledge the contribution of those who worked really hard to make this program happen. On behalf of Rajapalayam Rajus College and the entire fraternity of the institution, first of all, extend my most sincere thanks to the Almighty God for making today's event a resounding success. I extend a really hearty thanks to our chief guest, Dr. Krishna Kumar Narayanan, who spared time from his busiest schedule to grace the occasion and sharing his knowledge on mobile edge computing. I'd also like to thank our technicians who worked behind to make this event happen. My heartfelt thanks to all the participants for their cooperation throughout the program. Your participation is valuable for us. Thank you.
Sir, another question is there.
Sure. A fantastic question. I think I love this type of questions. Yeah, they're very different. I think I remember a few years ago people talked about fog computing, and the difference is there are the similarities is I would say there are more differences than similarities. The fog computing, what it does was it tried to cache some of the information that before it goes to the cloud. Let's say if you're frequently making any queries to the cloud servers, the fog layer would cache it. So it would act like a secondary layer for the cloud. So in that sense, it was not very it was not very popular. I mean, a lot of companies tried it. It didn't really take off very well. But edge computing has got a different purpose, right? Edge computing really spelled out exactly what those benefits are, and the technical benefits as well as the business benefits. And this is the reason why edge is really getting a lot of attention as compared to fog computing. But very good question. Yeah, please track those two closely, but less on the fog side, but more on the edge side.
Thank you, sir. Sir, another question is there, I think.
Yeah, so like I mentioned, 5G, it encompasses all the wireless network protocols. Of course, the Wi-Fi and Bluetooth are very commonly used. NFC is used at rare occasions, so it's going to be a wait and see approach in terms of what type of NFC applications are going to be coming in and leveraging the 5G networks. Is something that we have to wait and see.
Thank you so much, sir.
You're welcome.
I think queries are not displayed. Next, this is the end of session. I will wind up now. Our day 2 session will start tomorrow sharply at 10 a.m. Please join us and make our session a wonderful one. Thank you so much, and the feedback link will be displayed in our comment box, and it will be available up to 1 p.m. Thank you so much. So let us wind up, sir.
Thank you very much, madam. Again, on behalf of the IGL hands-on team, Rajesh Kumar Raghupati and Govind, Pradeep, Kaleem, and Meena, we would like to thank you for the opportunity for the International Faculty Development Program, giving us an opportunity to present our experience. Basically, we want to share our industrial experience with the educational community, especially colleges such as RRC. So we thank you for the opportunity. And this is not the only forum, so please feel free to reach any one of us and ask any questions along these topics. We'll look forward to hearing more from you, as well as more seminars in the rest of the week. Thanks once again for the opportunity, and it's our pleasure to serve RRC.
Thank you so much, sir. Thank you so much for Govind sir and Pradeep sir for joining this session today. And thank you so much. I wind up now.
Thank you. Bye
Thank
now.
you, sir.
Thank you.
Bye, sir.